Now we will see how to determine the pH during titration. First, we have two types of titration: titration of strong acid by strong base and titration of strong base by strong acid. First, titration of strong acid by strong base. We have two cases. First case, if the volume of base added is less than Vb added at equivalence, and second case, if Vb greater than Vbe. We will see the first case. How can we determine the pH of the solution in the beaker if Vb less than Vbe? In this case, number of mole of HO- added less than number of mole of HO- added at equivalence. Then number of mole of HO- added is less than number of mole of H3O+ introduced in the beaker. Therefore, the ratio of HO-, which is number of mole of HO- over 1, is less than the ratio of H3O+, and therefore H3O+ is in excess. Then the medium in the beaker is acidic. We need to determine the concentration of H3O+ left in the beaker to determine the pH. First, we write the equation of titration. H3O+ plus HO- give 2H2O. Number of mole introduced, number of mole of HO+ is equal to Ca times Va, and number of mole of HO- equals Cb times Vb. Number of mole left, HO- is the limiting reactant, then number of mole of HO- left equal to 0, while number of mole of HO+ left equals CaVa minus CbVb. Water is in excess before and after. Then number of mole of H2O+ left equals CaVa minus CvBv. Now the concentration of H3O+ left equal number of mole of H3O+ left over V total equals CaVa minus CbVb over V total. Since at equivalence number of mole of H3O+ introduced equal number of mole of HO- added, then we can say CaVa equals CbVbe. Therefore, we can replace CaVa by CbVbe. Then the relation becomes, we replace CaVa by CbVbe, CbVbe minus CbVb over V total. V total is equal to volume of acid plus volume of base plus volume of water added to immerse the electrode of pH meter. Therefore, the final relation Cb common factor remains Vbe minus Vb over V total. Now, the medium is acidic, then the pH equal negative log concentration of H3O plus equal negative log Cb VBE minus VB over V total. We replace Cb and V total by their value, and we calculate the negative log Cb over V total, and we find the final relation. Second case, if Vb added greater than Vbe, then volume of base added at X. In this case, number of mole of HO minus added greater than number of mole of HO minus added at equivalence, and therefore number of mole of HO minus added greater than number of mole of H3O plus introduced in the beaker, which means ratio of HO minus, which is NHO minus over 1, is greater than ratio of H3O plus, which is NHO plus over 1. And then HO minus is the reactant in excess. Okay, we need to determine the concentration of HO minus left. We write the titration reaction H3O plus plus HO minus give 2H2O. Number of mole introduced equal CaVa for HO plus and CbVb for HO minus. Water is in excess. Number of mole left. In this case, HO plus is the limiting reactant, then number of mole of HO plus left equal to 0. HO minus in excess, number of mole of HO minus left equals CbVb minus CaVa. Number of mole HO minus number of mole of H3O plus. Now, concentration of HO minus left equal number of mole of HO minus left over V total equals CbVb minus CaVa over V total equal. In this case, at equivalence, number of mole of HO minus added equal number of mole of HO plus introduced, then CaVa equals CbVbe. We can replace CaVa by CbVbe. Then CbVb minus CbVbe over V total. V total is V acid plus V base plus V base plus volume of water equal Cb common factor Vb minus Vbe over V total. Now the medium is basic, then pH equals 14 plus log concentration HO minus equal 14 plus log Cb Vb minus Vbe over V total. This is the case of titration of strong acid by strong base. The two cases where Vb less than Vbe and the other case where Vb is greater than Vbe. Second case, titration of a strong base by a strong acid. We have in this case two cases where Va less than Vae and the other case Va greater than Va. First case, If volume of acid added is less than volume of acid added at equals, then in this case number of mole of H3O plus added is less than number of mole of H3O plus added at equivalence. That means number of mole of H3O plus added less than number of mole of HO minus introduced. Therefore, ratio of H3O plus is less than ratio of HO minus. Then HO minus is in excess. The same, we need to determine the concentration of HO minus left without the titration reaction. H3O plus HO minus give 2H2O. Number of mole introduced, CAVA for HO plus, CBVB for HO minus, water in excess. Number of mole left, in this case HO plus is limiting, it remains 0. HO minus, it remains CBVB minus CAVA. Now concentration of HO minus left equal number of mole of HO minus over V total equals CBVB minus CAVA over V total. Since at equivalence number of mole of H2O plus added equal number of mole HO minus introduced, then CBVB equal CAVAE. We can replace CBVB by CAVAE minus CAVA over V total equals CA common factor VAE minus VA over V total. V total is the sum of volume of acid plus volume of base plus volume of water added to immerse the electrode of pH meter. Now the pH equal 14, since the medium is basic, 14 plus log concentration of HO minus equal 14 plus log CAVAE minus VA over V total. By replacing CA and V total by the value, we can deduce the final relation. Second case, if VA added is greater than VAE. In this case, number of mole of H3O plus added is greater than number of mole of H3O plus added at equivalence. Therefore, number of mole of H3O plus added is greater than number of mole of HO minus introduced, since at equivalence number of mole of HO plus added at equivalence equal number of mole HO minus introduced. Therefore, ratio of H3O plus is greater than ratio of HO minus, and the medium is acidic. That means H3O plus is in excess. We write the equation of titration H3O plus HO minus give H2H2O to determine the concentration of HO plus left. N introduced CAVA, CBVB for HO minus, N left CAVA minus CBVB for the excess, 0 for the limiting, water always in excess. Now, the concentration of H3O plus left equal number of mole of H3O plus left over V total equal CAVA minus CBVB over V total. And since at equivalence CBVB equals CAVAE, then we can replace CBVB by CAVAE. CAVA minus CBVB, we replace it by CAVAE. Our V total equals CA common factor VA minus VAE, our V total. Now pH equal negative log concentration H3O plus equal negative log CA VA minus VAE over V total. By replacing CA and V total by their value, we can deduce their final relation. These are the 4 cases to determine the pH during titration. Now we'll see 2 examples. First example, a volume VA equal 10 ml of the sulfuric acid solution S is introduced into a beaker, then 20 ml of distilled water is added in order to immerse properly the pH meter electrode. We have sulfuric acid H3O plus A minus of concentration Ca. We take a volume Va equal 10 milliliter. We then add progressively a sodium hydroxide solution of molar concentration Na plus HO minus of Cb equals 410 negative 2 mole per liter. The volume of base added at equivalence VBE equal 12.5 milliliter. Shows the relation which corresponds to the pH of solution after the addition of volume VB equal 15 milliliter. Is it A, pH equal 10.95 plus log VB minus VBE, or B, pH equal 11.2 plus log VB minus VBE, or C, pH equal negative log 8.810 negative 4 VB minus VBE. Then for VB equal 15 milliliter, that means greater than VBE. The number of mole of HO minus added greater than number of mole of HO minus added at equivalence. That means number of mole of HO minus added greater than number of mole of H3O plus introduced in the beaker. And therefore ratio of HO minus, which is number of mole of HO minus over 1, greater than ratio of H3O plus, which is number of mole of H3O plus introduced over 1. That means HO minus is in excess. Then the medium is basic. We should determine the concentration of HO minus to reduce the pH. We write the equation of the reaction H3O plus of titration reaction plus HO minus give 2H2O. Number of mole introduced CAVA for acid, CBVB for base, excess for water. Number of mole left. In this case, H2O plus is the limiting reactant. It remains 0. For HO minus, number of mole left equals CBVB minus CAVA. The concentration of HO minus left equal number of mole of HO minus left over V total. Number of mole CBVB minus CAVA over V total. At equivalence, number of mole of H2O plus introduced equal number of mole of HO minus added. That means CAVA equals CBVBE. At equivalence, CAVA equals CBVBE. Then we can replace CAVA by CBVBE. CBVB minus CBVBE over V total equal CB common factor VB minus VBE over V total is VA plus VB plus V water. We replace CB by its value 4, 10, negative 2, VB minus VBE over V acid 10, V base 15, and volume of water equal 20 milliliter equal 4, 10, negative 2, VB minus VBE over 25, 45 equal 8.88 10 to the power negative 4 VB minus VBE. Now we can determine pH. The medium is basic. pH equals 14 plus log concentration HO minus equal 14 plus log 8.88 10 negative 4 VB minus VBE equal 14 plus log A times B equal log A, which is 8.88 10 negative 4 plus log VB minus VBE equal 14 plus log 8.88 10 negative 4 equal negative minus negative 3.05 plus log VB minus VBE. Then pH equal 14 minus 3.05 equal 10.95 plus log VB minus VBE. This is the final relation. Then which one is the correct? It is A. pH equal 10.5 plus log 10.95 plus log VB minus VBE. Therefore, the correct one is A. Another example, a volume VB equal 20 milliliter of sodium hydroxide solution, Na plus HO minus of CB, VB equal 20 milliliter. We add 20 milliliter of distilled water to immerse the electrode of pH meter. Then we realize the pH metric titration using hydrochloric acid H3O plus Cl minus of concentration Ca equals 7.2 10 negative 2 mole per liter. The volume of acid added at equivals equal 16.8 milliliter. Now choose the relation which corresponds to the pH of the solution after addition of a volume VA equal 10 milliliter less than VAE. Then we have VA less than VAE. Which relation is the correct one? pH equal 2.84 negative log VAE minus VA or 14 plus log VAE minus VA or 11.16 log VAE minus VA. Since VA less than VAE, then number of mole of H3O plus added less than number of mole of H3O plus added at equivalence, before equivalence. That means number of mole of H3O plus added is less than number of mole of HO minus introduced, since at equivalence number of mole of H3O plus added at equivalence equal number of mole of HO minus introduced. Now, the ratio of H3O plus, which is number of mole over 1, is less than the ratio of HO minus, which is number of mole introduced over 1. That means HO minus is in excess. Then the medium is basic before the equivalence. We need to determine the concentration of HO minus left after the addition of 10 milliliter of acid. We write the titration reaction H3O plus HO minus give 2H2O. Number of mole introduced CAVA for HO plus, CBVB for HO minus, excess of water for water. And left, H2O plus is the limiting reactant, then it remains 0. HO minus the excess, it remains CBVB minus CAVA. Now, concentration of HO minus left equal number of mole of HO minus left over V total equals CBVB minus CAVA over V total equal. Since at equivalence number of mole of HO minus introduced equal number of mole of HO plus added, then we can say CBVB equals CAVAE. Then we can replace CBVB by CAVAE minus CAVA over V total equals CA common factor VAE minus VA over V total is volume of acid plus volume of base plus volume of water. We replace Ca by its value 7.210 negative 2, VAE minus VA, our volume of acid 10 milliliter plus volume of base 20 milliliter plus volume of water 20 milliliter equals 7.210 negative 2 VAE minus VA over 50. Now the medium is basic, then pH equals 14 plus log concentration HO minus equal 14 plus log 7.210 negative 2 over 50 equal 1.4410 negative 3 VAE minus VA. This is the concentration of HO minus left. Now pH equals 14 plus log concentration HO minus equal 14 plus log 1.4410 negative 3 VAE minus VA equals 14 plus log 1.4410 negative 3 plus log VAE minus VA equals 14 plus log 1.4410 negative 3 negative 2.84 then minus 2.84 plus log VAE minus VA equal 11.16 plus log VAE minus VA which is relation C, 11.16 plus log VAE minus VA. Therefore, the correct one is C. This is how to determine the pH during the titration when volume added less than VE or bigger than VE.